Hi everyone. So we've talked about geometric sequences, which is a set of numbers that's multiplying or dividing by something every time. Now we're going to talk about geometric series, which is like a geometric sequence, except for it has an ending point. It doesn't go on forever. And with geometric series, we can find sums of geometric series, which means that we take all of the numbers in the sequence and add them together. We can do that because it has an ending. So we use one of these two formulas, and it doesn't matter which one you use. It just depends on what information you've been given. And once again, these numbers or these variables are really similar. So a sub 1 is your first term, a sub n is your last term, your nth term, and then r is the common ratio, what you're multiplying by or dividing by. So let's just start with our first example, which gives us a sub 1 is equal to negative 3, a sub n is equal to negative 2,187, and r is equal to 3. So because it gave us our first and our last term, we can use that top equation, which is s sub n is equal to a sub 1 minus r. And we're just going to replace what we know. So s sub n is the sum, what we're trying to find. A sub 1 is negative 3 minus a sub n, which is negative 2,187, and then your r is 3. Recognize that I just put r. I need to put 3 where I put the r. That I put all of these numbers in parentheses. It's just so that I don't get confused with all of the minus signs. You definitely don't have to do it, but I would recommend it. Okay, so now we're just going to plug that into a calculator. Which gives me negative 3,279. And that's when I add all of those numbers up together. The first term, the last term, and then all the terms in the middle. Okay, let's go to the second example. The second example says negative 1 plus negative 5 plus negative 25 plus negative 125. And we know that n is equal to 8. So here's the deal on this. We don't have the last term. We do have the first term, but we don't have the last term. So we're going to actually end up having to use this bottom equation right here. And I'm going to just cut and paste it down here so that we have it down here. Okay. So now we have our first term, which is a1, but we do need to find the r, which is what you're multiplying by every time. So to go from negative 1 to negative 5, because it's going from a negative to a negative, I'm not multiplying by negative, because if I was multiplying by negative, it would have to flip-flop signs. But because it's going just negative to negative, it's a multiplying by positive, and I know to go from 1 to 5, I multiply by 5. But to double check, 5 to 25 is also multiplying by 5. 25 to 125 is also multiplying by 5. So we know that r is equal to 5. Now we should be able to plug everything in. Our a sub 1 is negative 1 minus a sub 1 again times your r, which we just decided was 5 to the power of n. Well, they told us that n is 8 over 1 minus your r, which is 5. Okay, so now we can plug that into a calculator, which will give us negative 97,656. And once again, that's if I wrote down all 8 numbers and then added them all together. This is just the easier, the faster way to do it. All right, let's go to the third example, which is really similar to what we just did. So the first thing I'm going to do is figure out what we're multiplying by every time. Notice that you're switching between positives and negatives, so we know we're multiplying by a negative, and it's getting bigger, so it's going to be multiplied by a negative whole number. To go from 2 to negative 8, I multiply by negative 4. So every time I'm multiplying by negative 4, which means my r is equal to negative 4, I have my first term, I have my r, I have my n, so I'm going to use that bottom equation again. I'm just going to cut and paste it again so that I don't have to rewrite it. Whoa. Okay, and let's plug in what we know. So we're going to get S sub n is equal to A1, which is our first term. That's 2. Minus 2 times your r, which we just decided was -4, to the power of n, which is 7, over 1 minus your r, which is -4. When I plug that into a calculator, I get 6,554. And that is our sum. Okay, and the last example, number 4, is actually that sigma again. Remember, sigma is a Greek letter. It stands for sum of. And we could potentially plug this into a calculator, but we can also use one of those formulas. And instead of plugging in, like finding your A1 and AN like we did for the arithmetic series, I'm going to show you a little trick. When it's set up like this, and there's a number inside parentheses to the power of n minus 1, that number is your r. That's just the way that these things are set up. And then if there's a number out front, that's your A1. Or your first term. Now, if there was no number out front, we could make your A1 a 1, because 1 times anything is itself, so I can just kind of shove a 1 up in front if there is no number there. Now that I actually have everything that I need now, because this 9 is your n, so we have n, we have A1, and we have r, so we can once again use this bottom equation that we have been using for the last 2 examples, and just plug everything in. So I'm going to end up with A1, which is 2. That's our first number. Minus 2 times your r, which is -5, to the power of n, which is 9, because that's just our top number on that sigma, over 1 minus r, which is -5. I'm going to plug that all into a calculator. And I get 651,042. So that's potentially, if I plugged in 1 to that equation, then plugged in 2, plugged in 3, all the way up to 9, and then added all of my answers together. This is how we find sums of geometric series.